Alright, hey guys, happy Thursday. Go ahead and get your math notebooks. Label it at the top. Today is December 10th. Alright, looking back yesterday, tell me what we learned about fractions. You can use your math notebook because you guys have some good information in there. Tell me, what is a fraction, Bradley?
A numerical quantity that is not a whole number. That a fraction is not a whole number.
Good. Who can add to what Bradley had? A key word that we talked about, that a fraction is a, Ben?
Half of a full number.
Not necessarily a half. If it wouldn't be a half, what kind of word can we use there? Because we don't know exactly what kind of fraction we're going to have. It could be a half. That would be a good example of a fraction. Raiden, what's that word?
Portion.
Portion? Good. What's another word? I like that word.
Equivalent.
Not equivalent, but we're going to talk about that one today.
Quantity.
Quantity. I like math words here, guys.
A fraction of a tiny part.
Yeah, a part of a whole. I like that. Good. What else did we learn about fractions? We know we have a top number and a bottom number, but when we talk about that, we don't want to say top number and bottom number. You guys are better than that. What kind of words can we use for that, Maverick? Denominator and? You're close. You got one.
Numerator.
Numerator. Good. Which is which? Megan, which is which?
Numerators on the top.
Good. Numerator is on the top, denominator is on the bottom. We talked about different types of fractions, and we know that sometimes fractions, normally our numerator is going to be bigger or smaller than our denominator. Justice? Smaller. But what happens, what is that called when our numerator is actually bigger? We don't like to see it like that. We're probably going to change it, but what's that called, Mason? Improper fraction. Good. What's it called when I have a whole number and a fraction together? Max?
A mixed number.
A mixed number. Awesome. Today in your math notebook, new vocab word, equivalent fraction. I want you to use your iPad. I want you to give me a definition and an example. Equivalent fraction. I've got some friends who got it already. Let's be patient while our other friends are still finishing up and writing. All right, math's on. I want you to turn to a friend and tell them, what did you find out about equivalent fractions? Math's on, and turn to a friend and tell them what you found. All right, share with me what you found about equivalent fractions, Mimi.
Equivalent fractions are fractions with different numbers representing the same part of the whole. They have different numerators and denominators, but the fraction values are the same. For example, you can think of 1/2, it means half of something.
Good, very thorough definition. So showing similar parts of a whole. What I would say about yours, though, is your definition talked about having the same numerators and denominators. That may happen, but not necessarily. That's not a must-have for an equivalent fraction. Hannah?
Equivalent fractions are fractions with different numerators and denominators that represent the same value, like 1/2 equals 2/4.
Good. And your definition talked about having different numerators and denominators, but actually kind of mixing yours and Mimi's. They may have a same numerator or denominator and be equivalent. Okay? So that's not a necessity. The main part of that you guys need to take away is that they have the same part of a whole. Okay? Give me some examples. Alyssa.
1/2 and 3/6.
She says 1/2 and 3/6. Good. Malia.
1/2 and 2/4.
1/2 and 2/4. Good. Ben.
1/2 and 4/8.
1/2 and 4/8. Good. All right, Malia, lights both off. We have a song. Pencils down. Just being a listener. Mr. Avania was probably jamming out this morning.
My ears, yes.
If there were 4 socks to wear, then we would say there'd be 2 in each pair. And one of the 2 pairs we can declare equals 2/4 of all the socks there. Drawing 1/2 and 2/4 on a number line shows they can be described with an equal sign. An equal value is what they're worth, so we say 1/2 is equivalent to 2/4.
Equivalent fractions is the name for fractions whose values are the same.
Once upon a time, there were 9 canaries on telephone wires sitting down in threes. Each wire contained 1/3 of the bird, so 3 nines is equivalent to 1/3. Drawing 1/3 and 3 nines on a number line shows 1/3 equals 3 parts out of 9. Therefore, equivalent is the word that describes 3 nines and 1/3.
Equivalent fractions is the name for fractions whose values are the same.
If the numerator and denominator share a common factor, then you can divide the top and bottom by the same number. On top and under, and say with satisfaction we find an equivalent fraction. And you can multiply the top and the bottom by the same number. On top and under, which is really a fraction whose value equals 1. And through this action we find an equivalent fraction.
Equivalent fractions is the name for fractions whose values are the same.
The values are the same.
Equivalent fractions is the name for fractions whose values are the same.
The values are the same.
Malia, right light on, please. All right, very nice. So you guys gave me a definition. Actually, do both lights, Malia. Sorry, kiddo. You guys gave me a definition. You guys gave me some examples. We were jamming out. Let's practice. In your math notebook, number 1. We have 2/4. I like starting with 2/4. It's a good, smaller, basic fraction to start with. All right, to make an equivalent fraction, ladies and gentlemen, I can multiply this numerator and denominator by the same number to get a similar part. Remember, our number's going to be changing, but it's going to be a similar part, just like they showed you yesterday in our circles. They used the bars, like a candy bar. Remember, he broke off the big piece for him to eat, and he gave his friend the small piece. So if this candy bar is split into 2 pieces, and I eat half of it, it's going to look like this. But let's say the bottom one, I wanted to share 4 pieces. And I gave away 2 of them. Is that still the same part?
Yes.
But that fraction's got to be a different number. How many parts do I have here?
2.
1 colored out of how many?
2.
How many colored?
2.
Out of?
4.
So do I have different numbers?
Yes.
The same part, right? Okay. All right. The easiest thing, guys, is going to be multiplying it by a smaller number. Okay? You want to get a bigger number, you're just going to make more work for yourself. So if I multiply my numerator and my denominator, always by the same number, let's multiply by 2. Okay? 2 times 2? 4 times 2? 8. Now, if we want to work with smaller numbers, because that's always easier, we want to make less work for myself, why would I choose 1? Isn't that even smaller?
Yeah.
Okay, so 2 times 1?
2.
4 times 1?
4.
Did I write a new fraction? No. So that's why 1 isn't going to work. Okay? But 2 works. I create a new fraction. Let's draw it out and look at it. This marker's done. Done with that one. All right, my bottom one though. Oh man, Mrs. Bush's art skills are gonna come out here, right? Think Mr. Boyer can do fractions? I bet you can too. He's smart, huh? Oh, you guys are smart. All right, 1, 2, 3, 4 out of 8. 1, 2. Okay, same parts. It's a little rough with mine. Okay, they're both right here though. Okay, same parts.
Yes.
2/4. 4 out of 8. Okay, same size parts, right? Okay. What you do to the top, your numerator, you have to do the bottom. I could not multiply my numerator by 2 and my denominator by 3. Okay? You can also divide. Okay? What if I had 2/4 and I divide by 2? 2 divided by 2? 1. 4 divided by 2? 2. Still going to be similar parts. Okay, so both of those are going to be equivalent fractions. All 3 of these, 2/4, 4/8, and 1/2. All going to be the same part. Okay? Number 2. Let's do 2/3. And let's make an equivalent fraction. What could I multiply them both by?
2.
I would do 2, guys. I would make it easy for yourselves. Okay? 2 times 2?
4.
3 times 2?
6.
You could do, let's say your favorite number is 8. You could do 8. You're still going to get an equivalent fraction. 2 times 8 is?
16.
3 times 8?
24.
Still equivalent. Okay? I'm not telling you guys you can't do it. You can. It's totally up to you. All right? Number 3. Let's do 6/9. You give me an equivalent fraction of 6/9. Brooklyn, what'd you do?
Times 2.
Times 2. And what'd you get?
12. 16.
Good. I want you to take 6/9 though, and I want you to give me an equivalent fraction dividing. Give me an equivalent fraction by dividing. Do you have a question or you have the answer? Good. We've been doing just divide by 2, right? Because we like our working with our smaller numbers. So 6 divided by 2, 9 divided by 2. What's 6 divided by 2? What's 9 divided by 2? I can't do it. What do you mean I can't do it?
Oh, you're gonna have to do a different number.
I'd get a decimal if I did it, right? So do we want to use 2? No. So you guys got to think about your math facts here. What would be a better number there to use? Kara?
3.
Yeah, 3 would be a good choice. Kara, 6 divided by 3? 9 divided by 3?
3.
Good. Number 4. Give me an equivalent fraction. Your first equivalent fraction, I want you to give me 1 by multiplying. Now, this bar right here I made, this fraction looks different. What did I do to this fraction bar this time? Aiden?
You made a
I made like a slash. Does that make it not a fraction? Is it something different?
still a fraction.
It's still a fraction. I just made the line like a slash. This way or this way. Same way. Yeah, if you, Bradley said he switched his. With you, when you rewrite it, if you want to rewrite it going across, that's fine. It's totally your preference. When I was a student, I always made my fractions like this. And now, as an adult, I do my fractions like this. I don't know why. Just habit. Just my preference, that's all. All right, so 7/21. Give me an equivalent fraction. Megan?
Times 2.
Times 2, and what'd you get?
14/42.
Very nice. I want you to take this fraction, and I want you to give me...
No, 42.
42.
Oh. Oh. Little different there, huh?
Little.
Okay, I want you to take this fraction, and I want you to give me an equivalent fraction by dividing now. Gotta think about those math facts here, huh?
What?
Give me an equivalent fraction by dividing. Raina?
7.
Yeah, because what's 7 divided by 7?
1.
21 divided by 7?
3.
Good. So the dividing ones we do have to think about a little bit more, don't we? Yeah, definitely easier just to multiply by 2. The dividing is definitely doable. Just takes a little bit more thinking. All right, number 5. Go ahead. Ooh, we got a big one here. Give me an equivalent fraction. Your choice. Turn to a friend. Tell them what you got as an equivalent fraction. Justice. Divide by 11, she says. And what did you get when you divide by 11? What'd you get?
The numerator is 11 and the denominator is 12.
She said 11 twelfths here. She divided by 11. Very nice. Now, I like Justice's tactic on this one because 121 over 132, that's already a big number, isn't it? I don't know that I would want to multiply that number. Again, you can, but just to get bigger numbers. I like working with smaller numbers, so I also would have divided to get some smaller ones. What's something else that somebody else did? So with equivalent fractions, we have lots of different answers, okay? We're not all going to have the same. Bradley?
I did times 2.
Okay, times 2.
So
And what did you get?
142 and 164. I got something different.
You're close, Bradley. Somebody help him out.
Max.
It's 242.
And
I messed up.
good. It's okay. Just math facts. Make sure you're adding correct. Or you could add here because you could do times 2 just means 121 plus 121. Or you can multiply it by 2 and actually do your multiplication. Okay, just keep a close eye out on those math facts. That's all. Number 6. Actually, I want to go back and point out something to you guys on the board. On Schoology, while you guys are doing your homework, if you're getting stuck, I put this image on Schoology. Malia, will you turn off the left light?
Yeah.
And this image has some helpful notes for you. It tells us what an equivalent fraction is, that it means equal. 2 fractions are equivalent if they are the same size or at the same point on a number line. And then it shows you an example of how you can multiply the numerator and denominator by the same number, or you could divide the numerator and denominator by the same number, okay, to have 2 fractions that have the same parts. All right, so if you get stuck and forget, this is on Schoology. Go back to it. You can reference this to help you out. All right, Malia, lights. Number 6. Let's do, I want you to give me 2 equivalent fractions here. Give me 2. Hey, Malia.
That's
2 equivalent fractions there. I want you to turn to a friend and share your 2 examples of 2 equivalent fractions.
So, first one I got 25 times 2 equals 25. 30 times 2 equals 60. The second one I got 25 times 3 equals 75.
I like that you're telling a friend how you got it, not just telling them what the fraction is, but what you multiplied or divided by to get it. Carly and Justice, share with each other, please. My glare. Oh, make the glare a fraction bar there. It's like perfectly in the middle. Listening in 3, 2, 1. Give me one equivalent fraction by multiplying. Aiden, by multiplying.
Multiplying by 2.
Good. And when you multiply by 2, what is going to be our equivalent fraction? 50 over?
60.
Good. Now give me an equivalent fraction by dividing. Maverick.
5.
By dividing by 5?
5 over 6.
Very nice. 25 divided by 5 is 5. 30 divided by 5 is 6. Both equivalent fractions. There are more options. You can multiply by 3, 4, 5. More options, but those are just the 2 that I'm going to do right now. All right, ladies and gentlemen, do you guys have any questions on equivalent fractions? All right, I'm going to show you one more video on some types of fractions, and then we're going to do our homework. All right, here we go. Lights, please.
Now that you know that fractions are special numbers written like division problems, we're going to learn about some different types of fractions and where they're located on the number line. Because fractions are division problems, their value depends on the top and bottom numbers and the relationship between them. There are a few basic rules about that relationship that will help us estimate the value of a fraction and know about where it should be on the number line. The first rule is, if the top number of a fraction is 0, then the value of the fraction is always 0, no matter what the bottom number is. For example, 0 over 2 and 0 over 20,000 are both just 0. I like to call these fractions zero fractions, because they equal 0. Oh, and by the way, you can never have 0 as the bottom number of a fraction because you can't divide something into 0 parts, so don't even try it. The next rule is this. If the bottom number is bigger than the top number, then the value of the fraction will be greater than 0 but less than 1. That means it'll be somewhere in this section of the number line. Any fractions that have values in this range are called proper fractions because we can use these values to represent smaller parts of things. Our third rule is this. If the top number and bottom number are the same, then the value of the fraction is always just 1. So whether you have 1 over 1, or 5 over 5, or 100 over 100, the value is always just 1. I'm going to call this kind of fraction a whole fraction, because its value represents 1 whole. Oh, and in case you're wondering, this rule doesn't apply to 0 over 0, because like I told you, having a 0 on the bottom of a fraction is a big no-no. Okay, our last rule is this. If the top number is greater than the bottom number, then the value of the fraction will be bigger than 1. That means it'll be somewhere in this section of the number line, which goes on forever. These are called improper fractions, because even though they're written like regular fractions, since their value is greater than 1, they aren't really used to represent smaller parts of things. All right, these rules show that we have 4 main types of fractions. We have zero fractions, proper fractions, whole fractions, and improper fractions. Knowing that these main types are in order from smallest to largest on the number line allows you to do some very simple comparisons between the 4 types of fractions. That's because we know that a zero fraction is always less than a proper fraction, and a proper fraction is always less than a whole fraction, and a whole fraction is always less than an improper fraction. Let's do a few comparisons to get the hang of it. Here we have 1 over 5 and 0 over 8. Since 1 over 5 is a proper fraction and 0 over 8 is a zero fraction, 1 over 5 is greater than 0 over 8. Now let's do 3 over 8 and 2 over 2. 3 over 8 is a proper fraction and 2 over 2 is a whole fraction. So that means that 3 over 8 is less than 2 over 2. Now what about 9 over 9 and 32 over 32? Now that's easy. Since they're both whole fractions, and whole fractions are always equal to 1, these fractions are equal. And finally, what about 1/2 and 5 over 4? Now we know that 1/2 is a proper fraction, but 5 over 4 is an improper fraction because its top number is bigger than its bottom number. So that means that 1/2 is less than 5 over 4. Now that we know that there are 4 basic types of fractions, and we've learned where they fit on the number line, let's learn more about how the relationship between the top and bottom numbers affects the value of a fraction. Let's go on a journey down our number line. Now we're going to start with this 0 fraction, 0 over 20. And its value puts us here at 0 on the number line. To get moving, all we have to do is start changing the value of our fraction by increasing the top number. We're going to leave the bottom number the same the whole time though. All right, let's go. We haven't gotten very far from 0 yet, and you might have noticed that the top number is still very small compared to the bottom number. But as the top number gets bigger, the value of our fraction is increasing. That tells us that if a fraction's top number is a lot smaller than its bottom number, then its value is going to be close to 0 in this part of the number line. Look at this. We're almost to 10 on top, and since 10 is half of 20, we're almost to 1/2 on the number line. It's pretty easy to figure out what half of something or double something is, and we can use that to help us compare fractions. Like we know that 9 over 20 is going to be really close to 1/2 on our number line. All right, so we've passed 1/2 now, and we're making our way to the number 1. Notice that our top number keeps increasing, and it's getting closer and closer to 20. In fact, when it reaches 20, we'll have arrived at 1, because 20 over 20 is a whole fraction. Knowing this can also help you estimate a fraction's value. Whenever you see a fraction with a top and bottom number that are almost the same, like 19 over 20, you know that the value is close to 1. There, we've passed 1 now, but we're still 1, and our top number is now bigger than our bottom number, which means we have an improper fraction. You can see that the bigger the top number gets, the bigger the value of the fraction. And we could keep on going forever, but that might take all day. Okay, so our journey showed us some pretty useful regions of the number line. The region near 0, where the top number is much smaller than the bottom number. The region near 1/2, where the top number is about 1/2 of the bottom number. The region near 1, where the top number and bottom number are about the same. And the region past 1, where the top number is bigger than the bottom number, and it keeps on going forever. Knowing about these regions can sometimes help you quickly estimate the value of some fractions. For example, you can estimate that 1 over 16 is going to be pretty small, close to 0 on the number line. And you can estimate that 29 over 31 is going to be almost 1 because there's not much difference between the top and bottom numbers. And if you have the fraction 14 over 30, you can estimate that it'll be about 1/2, since 14 is close to 15, and 15 is half of 30. All right, that wraps up this section.
Lights, please. All right, so good fraction knowledge there that he's sharing with us. You guys today have an assignment over equivalent fractions on vocabulary. All right, any questions for your math? All right, ladies and gentlemen, you may get started.